Hi everyone, welcome to our channel if you are new here, or welcome back if you've been here before to learn more about SDC Verifier software. In this video, you will learn how to import a model into SDC Verifier. Import function, which is located in File section of the ribbon, automatically creates a new SDC Verifier project from current model or updates opened project with imported CAD geometry, finite elements model, or analysis results. If to briefly give an overview of the menu, geometry updates opened SDC Verifier model by reading existing CAD geometry. If SDC Verifier project is not opened, a new one will be created. Femap model is used for opening and reading items of existing finite element model created in Femap and starting a new SDC Verifier project. And model files like .modfem, also .mod or neutral files can be imported. Analysis model is able to read a file with finite elements model to SDC Verifier project. And about the analysis format, well, Nastran here has the particular options, and the options like this. Now, moving on, analysis results option reads file with results of finite elements model analysis to SDC Verifier project. The project parts from file imports project parts like views, components, recognition tools, reports, etc. from the selected file like .sdcpp. It is essential to mention that project which uses different model from the one the information was exported should be checked manually, as the IDs of the items, for example elements, materials, loads, can be different, and consequently some information can be mixed up or will not exist. Now it's time to import a model. So press Femap model, select the relevant model. Here you can check the model files, the types, press open. And here we go, the process was pretty fast, especially if we consider the size of the model, 54,603 elements. In model section of the tree, I'm expanding properties, and we can see that they have successfully been imported as well. Also, we can see fem loads and constraints, and based on which individual loads can later be created. Moving on, I would like to give you a brief overview of the View Style menu. By expanding this menu, you can see a variety of options. This is how they are currently on and off immediately after importing the model. We can see the filled edges, shading, mesh size locations, and offsets are active. I will gradually activate and inactivate them so that you can see how they affect the view style of the model. So, wireframe displays only the edges and curves. So I activated it, and we can notice that shading is off automatically. Now moving on, hidden shows hidden lines. Solid turns both fill and shading on. Fill option fills in edged entities with color. Filled edges enables filled elements to appear on screen and can be controlled without showing elements' edges and surfaces, which make up solids to appear without solid curves around the surfaces. Feature lines outlines different parts of the model using only mesh edges. Now, when curve connectivity is on, curves are displayed using different colors that represent different types of geometric connections. Shading and transparency can be toggled on and off. You can see that shading is on. Now I'm turning on the transparency. Mesh size and locations can be on and off as well. I'm turning the transparency off. Now let's move on to shrink. It shows elements at a specified percentage smaller for visualization purposes. And offsets, which refer to intentional shifts or displacements of structural elements, can be on and off as well. Orientation refers to the spatial alignment of elements relative to a defined coordinate system. I switched it on and you can see arrows that show the orientation. Again, it can be on and off. Thickness and cross-section switches shell elements thickness along with beam bar elements cross-section, again on and off. Now you can see that it's on. Meanwhile, we can turn the orientation off. Okay, moving on. Color with menu allows to choose the element color mode. And options are to color the elements with, for example, element colors, which is on, property colors, as well as material colors. Now, work plane. Work plane is an additional plane with, so to speak, independent coordinates x and y. It facilitates modeling of geometrical items, and their coordinates on the work plane automatically move around into the current coordinate system. It can be on and off. Now, clipping plane. It is a 2D plane that temporarily removes or obscures portions of a 3D model on one side of the plane. So clipping on. Now clip positive side plain. The third option, which is plain, can be defined manually. Now, last but not the least, some advanced options. You may set view parameters. Here you can see the categories like this with certain options. Font can be defined, color and background. Also, the category like this can have the following options, and post-processing also has these options. Okay, if you have any other questions on how to get started with SDC Verifier software, our online help may come in handy. So go to Software, Online Help, Help for SDC Verifier. Thank you for watching. Hit that like button, ask us questions in the comment section, and subscribe to our channel for more videos to come. Also follow us on social media to receive updates first while keeping up with us. All necessary links are pinned in the comment section below.